So this is the paper that we were talking about that yesterday, and I sent it to you. So the equations that we mentioned here, it's the first one. Okay, so this is the first equation that we mentioned, and you can see that all these terms are added together. Okay, but I guess in the, the PowerPoint, some of these were, so the point is that you can put, you can add these terms together, but finally our coefficients will be negative, as we expect that the amplitude to decrease by increasing distance. Okay, so it really doesn't matter if you put minus here or here, then NF will be a positive value and K will be a positive value. Or if you put a negative, if you put a positive here and you add them together, then your coefficients, which are Ka, Kf, and NF, will be negative. So just to keep it in your mind. So everybody has access to Matlab, right? I need your approval.
Yes, yes.
Yes.
Yes, yes.
Yeah, because today's I will not be the only speaker here, and we need to interact to each other. So and probably at some point you also need to share your screen, and you let me share my Matlab window if I can find it here. Okay, here you are. So do you all see my Matlab command window?
Yes. Yes.
Okay, great. So please open also your Matlab, and we need to interact, and we will do something together. And in the meanwhile, you can tell me that, are you familiar with Matlab, and how familiar are you with that? I mean, we have to start from some point, please. Tell me that if you are familiar with Matlab or not. It doesn't really matter, but I need to know that.
No. No.
Okay. So this is a no for everybody. That's great. So this is a good point to start. So this is the Matlab main window, right? Matlab is a commercial, let's say, software package, and there are some free versions of. They are not actually Matlab, but there is something called Octave, which is freely available, and most of the commands are the same, and the environment is also the same, and it's quite powerful. So here you can see this window over here. This is called command window. Then we have workspace, that all the variables that you introduce will be shown here. You have also something else over here, which is command history, and you can, all the comments will be stored there. So we can start from the very beginning. So in Matlab, you can do elementary operations. For example, 7 plus 12, it gives 19. Or you can do the operation like multiplied by minus 13, 8.5. This is multiplied by minus 13, and you will get the results, or you can do 2 divided by 3 or 3 with power of 2. Okay, I ask you guys to please follow the things that I'm doing. In the meanwhile, and if you're lost, just let me know and we can return to that. And okay, but you need to follow me. So everybody have tried these operations?
Yes, yes.
Okay, so we have also some logical operations. Okay, so for example, 2 is equal to 3. And the answer is 0. And it's a logical 0 because 2 is not equal to 3. Or we have 2 is not equal to 3. So the answer is 1. It's true. The first one, it was false, and this one is true. It's logical true. We can also say 1 and 0. So what do you expect this to be? Just consider that 1 is true and 0 is false. Then 1 and true should be false or true. Any idea?
Yeah.
So I cannot see the right. You have to the point.
Cannot see the bottom of your screen.
Okay.
Yes.
So,
Logical 0.
can you see that now? Can you see? Can
Yes.
you see it? Okay.
But maybe can you see it, Dung?
So everybody can see this moving.
For me, I can see it.
Dung, can you see that?
Now it's fine. Thanks.
Okay.
Yeah, I can see.
Okay, so perfect. So then please tell me that what is the result of this one? 1 and 0. So it means true and false.
It's false.
Okay, perfect. It's false. What about 1 or 0?
True.
Perfect.
True.
Yeah. So we have also XOR. Are you familiar with that? XOR is
No.
logical exclusive OR. Okay. For example, let's try with this one. Okay. So it returns 1. Why is that? Because XOR of this one is true if A or B, but not both of them are true. Just one of them is true. Okay, then XOR will be true. This is exclusive OR, logical exclusive OR. So we can also try 1 and 1. Then what it should be?
It should
True.
be false.
Perfect. So what about this one?
Should be true.
Great. And what about this one?
False again.
Okay, perfect. So we have also some other sort of logical operations. For example, t is equal or smaller or equal to 1. Of course, it's false. We have also 3 is smaller than 1. False. Or 3 is greater than or equal to 1, which is true, or 3 is greater than 1, which is true. Okay, so these are the logical operations so far. We already introduced the elementary operation, summation, multiplication, division, and power. Just to recall you, this is for summation, subtraction, division, and power. Okay. Then we will talk about variables. Okay, for example, I can write A is equal to 2. So it assigns variable A to 2. And here, let me just. So here, A is equal to 2. So here in your workspace, you have to see a variable called A, and it's 2, right? So this is how you can assign a variable to a sort of number or whatever you want. Or for example, A is equal to 6. Okay, then A is changed to 6 now. Okay, then we can also use strings. For example, hello. S is hello. You see? Then when we want to we want to assign a string to the variable, we have to use quotation marks. And you can also use this type of quotation marks. And myself, I prefer this one. And we will see that later on. Okay, so this is a variable, a string variable, and you can see that this is string. The type of the variable is string. Okay, then we have S is here, and if I just type S and press enter, it will write the variable here, or A. Okay, then for example, I can also store logical variables. For example, A is equal to 3 larger than or equal to 1. And then A is true, or A is equal to 3 smaller or equal to 1. And that A is a logical variable. You see, it's logical now. So 0 means false and 1 means true. So we have a command CLC. This is when to get to clear your command window. You see when it's like clear in bash script or this stuff. Okay, so CLC is to clear your command window. And okay, so we have some predefined variables. For example, pi. So this is pi, or let's put p equal to pi. Then we have format short. So, and format long. Oops. Oh. Okay, so then when I use format line and print p, this is pi. Okay, when I format short, oh, why? So it seems that today I'm not ready. So format short, this is pi. So format short, when you use format short, it will result in displaying to a small number of decimal places. And when you use format long again, and p or pi. Okay, then p will be displayed to more decimal places. Okay, let me just keep it format. So then we have vectors and matrices in Matlab. Okay, so CLC to clear. Are you following me?
Yes, yes.
Yes.
Yeah. I mean, at any point, if you are lost, just let me know, because this is not like a lecture, and we need to get our hands really dirty on that. So
Okay.
we can define A is equal to.
Excuse me.
Yeah.
I was saying when we're using the format long and format short, is it that the format is used for the print out or something?
No. Just let me try format short, and then P is equal to pi, and then P. Okay. So this is P. Okay. And then format long, and P is equal to pi. And you see, this is P.
Oh, okay. So if we want to print,
let me do it again. Okay. And again P.
Okay.
You see, they're the same.
Yeah.
But the point is that when you want to display this, so it really, so we can do it again to make it as clear as possible. So now format is supposed to be short, right?
Yes.
Let me clear everything. Okay, we don't have anything in the so format short, P is equal to pi. Okay, what is displayed here is this one. And if you go to the workspace, what is by default displayed is like format short.
Okay.
But if you double click on that, you see too many decimal points. Okay, so let's try with format long. Okay, and then assign P to pi to P again. Okay, so this is with format line. You see that the format line is like that. So when you use format line, the more decimal places will be displayed. Right?
Okay.
Clear?
Clear. So we don't need any print and maybe an input if you want to. When I want to print something on the screen, I don't have to type in.
If it's
like
already
in Fortran, Fortran, I have to do print.
Yeah, we will reach to that.
Oh, okay.
But that's a good question. So when you have one variable in your workspace like P, you can display it in different ways. So just P. Okay, P and press enter.
Okay.
It will show the variable. The other way is to use disp. You see?
Yeah.
This stands for display. We will see that later on.
Okay.
So the other
Prof. Hello.
No.
Why it assigned in 4 decimal places? Why not in 5 or in 3 decimal places? I mean 3.1416. Why not 3.147? I mean in 3. When you say format short.
Just a second, I need to put my headphones on because I cannot hear you very well.
Okay. You are saying, can you hear me?
Please quit him.
Don't you said?
I mean, please quit him.
Okay. Kumsa, do you mean?
Yeah. Yeah. My
why-
question is,
why the decimal place is in maybe where is it, sir?
Okay, so
like in 4 decimal
please.
place.
yeah, is it by default? I mean, it's like,
So what is by default? Can you repeat your question, please?
my question is, why it's when you say format short, it's put in 4 decimal places. You see,
Yeah.
why not in 4 or in 2 decimal places? That's my question.
Yeah, when you write format short, it only affects the value that will be displayed. Okay. And
Yeah.
when you write format long, the display value, this is quite important because at some point you want to control your variables, and if you have too many decimal points that are not necessary, then it can be quite confusing, right? So it's about displaying the variables, the number of decimal places that will be displayed. Is that your question or what?
Yeah. Okay.
So we have vectors and matrices. So let me clear here. So we have a command called clear, and it will clear all the variables in the workspace. You see, we have P here, but if I type clear and press enter, we have nothing. Okay, so let me CLC and let me define a vector, a matrix 1, 2, for example 3, 4, then 5, 6. Oops, 6. Okay, this is A. So if I put a semicolon at the end of the command, you cannot see anything on the command window. But if I remove the semicolon from the end of the command, the result will be displayed on command window. Okay. So this is a matrix of 3 by 2, and it's stored in the workspace, and we can see that. So another way to generate this matrix is, so how did I generate that? When you put space here, it means that you are in the same row. And as soon as you put semicolon, it means that you are moving to the next row. Okay, so for I type here 1 space 2. So it means that the first row is composed of 1 and 2. Then semicolon tells that, okay, go to the next row. And then we have 3 and 4. And then semicolon for the third row, and it's 5 and 6. So the other way to do that is you can also use comma instead of these spaces. For example, oops. So, and the result would be the same. Okay, so comma and a space means that you are in the same row, and semicolon means that you go to the next row. And A is a 3 by 2 matrix. So this is how you can make a matrix. Then vectors. So we can make a vector again with the same command. So a vector of 1, 2, 3. Okay, and V, this is the vector. And you see that the size of the vector is 1 by 3. So it's a horizontal vector. So another way to do that is, and let me generate another vector, 1, 2, 3. Print it out. So VC is another vector. So V is a horizontal vector and VC is a vertical vector. So it's actually 1 by 3, the horizontal one, and it's 3 by 1, the vertical one. Okay, another way to
excuse me,
okay.
can you hear me?
Yeah.
Yeah, so when we are displaying that, when we are doing it in the vector form, the bracket, we should introduce the semicolon. But in the matrix, we don't bring the semicolon at the end of the closed bracket.
No.
Okay.
So you are talking about this semicolon?
Yes.
So this semicolon has nothing to do with generation of the vector or matrix or whatever. This semicolon, if you put it here, it tells that, okay, when you did the operation and the command is done, don't show the results on the command window. And if you remove it, let me show you again. So CLC. So everything is clear here. So we make the, and let me also clear the workspace. So so here I generate a matrix, a vertical vector of 1, 2, 3, right? And if I put this semicolon, when I press it, the vector is already generated, but the vector will not be shown on the command window.
Oh, okay.
So if I remove this, then the results will be shown here.
Okay.
So this is quite important because when you are writing a code and you are running a code, when the variables will be displayed on command window, it's quite time consuming and your code will be very slow. So you have to avoid that. If you are not going to control anything, you have to avoid showing everything on the printing everything on the command window because the code will be quite slow. So this is the semicolon at the end. This is about that. So we already, so you already learned about vertical and horizontal vectors. Then another way to produce such a vector is to use this command. V is equal to 1 colon 1 colon 3. Okay. This command sets V to the vector that starts from 1. Okay. And this increments 1 is also here and it ends with 3. So 1 with increment of 1 to 3. And this is V. So this is similar to this command. Okay. For example, if you want to make a horizontal vector of 1 to, let's say, okay, if your increment or a step is 1, then you can also use this one. So if increment is 1, the step from the start point to the end point is 1, then you can just simply neglect it. But just imagine that you want your vector from 1 to 3 with steps of 0.1. Okay. You see? 1, 1.1, 1.2, 1.3 to 3. So this is another way to make vectors, or for example, another example. Let me clear it here and sort. Okay, another example should be like V is equal to 1 with steps of 0.5 to 2. Okay. So this is another command for generating a vector. So I have this vector. So is it vertical or horizontal? Hello?
That's horizontal.
That's a horizontal. So we simply want to convert it to a vertical. So this is the command that we use, right? So we can transpose it. This is horizontal, but we didn't store it. V is still a horizontal vector, but what we displayed here, because it's not assigned to any new variable, it's vertical because this is for transpose. Okay, it changed the vectors with the rows and columns. It turns the rows to the columns. Okay. So, yep.
Does it
I cannot hear you.
To matrix? I'm saying, hello.
Yeah, I guess your connection is not very good, but if you can also use the I don't know, is it possible to write in the chat if your question? So you can hear him, the others, or this is only me?
Innocent. Yeah, I think your
Yes,
network
yes.
was unstable, so speak again.
Are you hearing me now?
Yes, I can hear you.
I know.
Okay. I wanted to know if this transpose applies also to matrix.
Yeah, exactly.
Yeah.
Okay.
Exactly. So we can try it again. Okay, so we have a vector, we have a matrix here. Okay, this is A, and this is A transpose. So it's working, right?
Okay.
Yeah, but the point is that we just displayed the transpose here, but we didn't store it in a variable. So if you want to, you can, for example, write A is equal to A transpose. Okay, then it will be stored here. Or if we do it again, it will be like that. Okay. So we can generate a vertical, a column vector with, for example, this is another way, 1, 2, 4, and so if we don't put transpose here, then it will be vertical. VC is vertical. And you already know how to, so what is this command doing? It starts from 1 by a step size of 1 because we didn't mention the step. So by default, it's 1 and it ends with 4. Okay. And by default, this 1.1 column 4 generates a horizontal vector. When we put it here in bracket and transpose it, then it will make VC. We generate VC as a vertical vector. So what else? Okay, so we have also command once, for example, 3 by 2. Okay, with the command once generate 3, 2. Okay, once 3, 2 generates a matrix, a 3 by 2 matrix that all its elements are 1. Okay, For example, we have also A equal to zeros, 3 by 2. Okay, zeros generates a matrix with 3 rows and 2 columns, and all the elements are 0. Okay, still with me?
Yes.
Yes, yes.
Okay. Then what else? Okay, just check the transpose again here, for example. And okay, for example, we can use this once command to generate, for example, if we do that, 3 multiplied by once, 3, 2. So what would be the results? What do you expect it to be? It will generate a 3 by 2 matrix.
Okay.
Okay.
Yeah.
Go ahead.
Yes, Professor.
It will display a 3 by 2 matrix with 3 values.
Okay. All the elements will be 3.
Yes.
Okay, great. So, or you can do some other stuff, for example, plus,
I think someone wanted to talk. Tarek.
Okay.
No, I just want you to clear everything and to go to the top of the command window, because I'm not able to see the bottom.
Oh, really? Okay. So CLC. When you cannot follow it, just let me know, and I mean, then I can clear it, because it's strange. You cannot see here. Okay. Okay, so we introduced ones, we introduced zeros. Let's try with some other ones, for example, 1 and 3. So what would be the results of this?
It will display 1 by 3 matrix with 1, 1 values.
Okay, so it generates actually a vector, yeah, a horizontal vector of all 3. So this was this, and then 0, and okay. So for example, just time to time, you need to remind me to clear that so everybody can see. We have a function rand 3 by 1. Okay, so rand actually generates this comment here generates a 3 by 1 vector or matrix of all random numbers, but the point is that this rand number is generates the random numbers between 0 and 1 with uniform distribution. Okay, so the distribution would be random. For example, uniform. So let's try with some other. So it generates 3 by 2 matrix, and all the elements are random numbers uniformly distributed between 0 and 1. Or we can try it again, and you see that the result is different. So each time that, every time that I try this one, the result will be different because they are random numbers. We can try it. Just to clear it. So this is one, and then this is another one, and you see that the results, every time the results will change. So we have a common histogram, okay, and let's put rand with 10,000 numbers and one column. So can you see also the figure? Can you see
No.
the generated figure? So did you try that? Did you
I
try
don't
this
see.
command?
Yeah, I tried and I got bigger.
Okay, so let me stop sharing and okay, Dun, can you share your figure, your output figure?
Just can you see it? Yes.
Yeah, perfect.
I'm sorry.
Yeah, that's great. So this is the histogram of the random. We generated 10,000 random numbers, and because we used rand command, these numbers are supposed to be uniformly distributed between 0 and 1. And you can see here that they are uniform, they're following the uniform distribution. Okay? Thanks, Zoom.
Sorry.
So, did you all try that?
Yes, yes.
Yes.
Okay, so one of you, please. Let me. Okay, so we can also do this, and we can type the same command and add comma 100 here.
Excuse me.
Yes.
I've typed it, but I cannot see the image. Okay, it has come. It was at the background. It has come.
You cannot see the image. The
Yeah.
image is the figure is generated or not?
Yeah, it's generated. I've seen it now. It was at the background, so I couldn't see, but now I've seen that it was at the background.
Okay, perfect. So try also this one, add 100, comma 100. And this is the number of beans. So you saw that, just try this one and then share your screen and show me the results. Show me and the other. So have you done that?
Yes.
Okay, so Tariq, can you show me the result?
Okay. But I'm using my desktop for Matlab and my laptop for Zoom, but I can show you with my webcam, okay?
Okay, no, it's not necessary to do that. Okay.
Where is it?
Perfect.
Okay.
Okay, perfect. So everybody generated this random number, 10,000 random number, and you see that the histogram proves that they're following the, let's say, uniform distribution. Okay.
Yeah.
So
yes.
we have another command, rand n. Okay, can you see? So this also generates random numbers, but the difference is that this n tells us that this is following the normal distribution, Gaussian distribution, with mean of 0 and a standard deviation or variance of 1. Okay, this is the difference between rand and rand n. So this produces a 3x2 matrix that all its elements are following the normal distribution with mean of 0 and a standard deviation of 1. Okay, let's try the last command again, but with rand n. So did you do that, everybody?
Yes.
Perfect. One of you, please.
It's a Gaussian curve, like.
Exactly. Yeah. So
Like
thanks,
this.
Tariq. So I want some others to share their screen. Thanks, Tariq. I saw that.
Yeah,
Perfect.
you've seen it, right?
So it's Yakub, right?
Yes, yes.
It's amazing that you need to. Okay, perfect. Any others? So Innocent.
Using a phone for Zoom and laptop for doing all of these tasks. So
Okay.
I don't know how I can.
Okay.
But it's
anyway.
okay. It is a boolean I can see.
Okay, so you produced that.
Yeah,
A random number
yeah.
is already produced. Perfect. So let me share my screen again. Okay, so you can see my screen. Okay, so that was about rand and rand n, and then what else can we say? Okay, let's try with something else. Okay, generate this figure again. Okay, and then type hold space on. Okay, did you do that? And then generate and then plot another normally distributed random number, but add +4. So what does this +4 means? So we generate another set of 10,000 normal distribution random numbers, but we add all the values with 4. So I said that the mean value is supposed to be 0. Okay, and on your histogram, you can see that the mean is about 0. And when you add 4, then it will be shifted and you will get, and hold on means that it will be plotted on the other one. So it will be superimposed on the other histogram. Please also try this one.
I got it.
Okay, can you share your screen?
Like this?
Yes.
I have to stop sharing.
Is it like this?
Yeah, perfect.
Yeah. Oh, the same, I think.
Okay, I guess the first one is produced. So this is you, Dung. The point is that the first one is produced by rand. You see that this is not following the blue one. This is not following the normal distribution. This is uniform distribution. So to get something similar to the others, you need to also, just close this figure. Oops. I mean, you can try it again and show me the results. This was a sort of trick to see that how we can change the mean values of the random numbers that we have produced. So did you get the results, Dung?
Okay, could be.
Oh, another point. Let me tell you this one. So the result should be something like that. You see?
Yeah.
So this is the first set of 10,000 random numbers that I produced. And you see that the mean is about 0, okay? And the standard deviation is about 1. And this is the second set of 10,000 random numbers that I produced, and I added all of them by 4. So the mean now is about 4. So at some point you need to generate some random numbers with different mean value. Okay, so this is it. And then what else can we do? Okay, for example, let's see. We can generate another set by 2.5 multiplied by rand n 10,000 by 1, and for example plot 4. So what do you think, guys? What is the results of that? I mean, from the statistical point of view.
It should be a distribution with a larger standard deviation and with the mean about 4.
Perfect. So the standard deviation would be larger. So we already produced that. And just histogram and G. Or to make it nicer, with 100 bins. So this, the second argument here is the number of bins in the histogram. So everybody has done that? So did you guys do that?
I typed it, but what displayed is strange. I don't know.
Okay.
It initially displayed the figures, but it has turned to something. Let me show my screen to you.
Okay, let me stop sharing. But just before that, okay, go ahead. Oh, what is this?
Okay, just what is this?
I don't know.
I don't know.
Okay, you can always, okay, another point. You can always control and C to kill the program that is running.
Control K.
Control and C.
Okay.
If you want to kill the program, you can just simply press Control and C. Okay, let's do it in another way. So we generate a random. Please, all of you, follow this one. So this is, you already know what is this. It generates 10,000 numbers with normal distribution, and then we multiply that by 2.5 and we add it by 4. Okay, and we store it in G, in a variable G, and put the semicolon here because you don't want to see 10,000 numbers on your screen. Okay, so this is what we already have. Then type histogram G with 100 bins. Okay, it will generate this figure. Can you see that?
Yes.
Okay, so we want to see what was the effect of adding 2.5, as Simone said. Let me share my command window again. Okay, so as I told you, we can use hold on to plot on the same figure again. Okay, hold on, and then we produce another random distribution, but this time we will not multiply it by 2.5. Okay, 10,001, but plus 4. And we store it on a variable called GG. And then we plot it again on the same figure with 100 bits. So did you do that, everybody?
Yes.
Yes.
Perfect. So let me share the result. And you have to get something similar to this one. It will never be the same because we are talking about random numbers. Okay, but the shape should be the same because they are following the same distribution. They are all normal distributions. So you also got the same thing. So the blue, yeah, did you get the same result?
Yes, yes.
Okay, so the blue is when we multiply that by 2.5, and the brown is when so it means that the variance is larger, and for the brown one, I don't know if it's brown, but whatever. So the variance, we didn't change the variance, and the variance is 1. Okay, but the mean value for both of them are 4 because we added 4 to that. Okay, so this was about random numbers. What else can we do? Okay, so we already have 2 different sets of random numbers here. We can write mean G. It's very close to 4. So mean returns the average, the mean value of the vector G, which is composed of 10,000 random numbers. And as we expected, the mean value is very close to 4. Okay, so STD returns the standard deviation. And you see, it's very close to 2.5 because Tariq, can you see the command window here, or I reached to the end?
No, I can see it in there.
Okay, perfect. So you remember that we multiplied that by 2.5. And I said that the standard deviation will be 2.5. And here STD returns the standard deviation, that you see that it's very close to 2.5. So GG is supposed to have the standard deviation of 1 because we didn't multiply it by anything. Okay, so let's try with GG. Mean GG is about very close to 4, and STD GG is very close to 1. Okay? So the other point, okay, so okay, so we have another command, norm fit. So it fits the normal, so it fits the normal distribution.
Please, I cannot.
Oh, you cannot see that. Okay, so let me see. Okay, so we have, let's say, mu hat and sigma hat is equal to norm fit G. Okay, so another function is norm fit. It returns the normal parameter estimates. It's the same. So the mu hat is actually mean, and the sigma hat here is a standard deviation. Okay, So these names are not important. You can put whatever you want. You can put A and B, okay? Or you can just put the results in one variable, A, okay? It depends what do you want. So if you put just one variable here, then it will take the mu, the first one, which is supposed to be mean. So this was about norm fit. And okay, so another command is I, for example, 4. So this generates identity matrix. Okay, for example, so when I put 4 here, it generates a 4 by 4 identity matrix. When I put 5, it generates a 5 by 5 identity matrix. And for example, if you want, we can write 3 multiplied by I5. What would be the results?
The diagonal is 3, 3, 3.
What? Come again, please.
The diagonal will be 3, 3, 3, and the rest will be 0, 0.
Exactly. Okay. So this is identity matrix. And so another important point is help command. Okay. We want to see what does, let me clear here. Myself, I need to use this help command because I don't remember all these comments. So for example, help I. So it shows you a brief explanation of the command. I identity matrix, and how the syntax is like I n is the n by n identity matrix, and so on. The other way is to just press this one here, and you will have access to a nicer view of the help command, and you can search whatever you want. Okay, so this is help. And then, okay. So for example, we can generate another matrix like this. So this is A, and size A tells us the size of this matrix, which is 3 by 2, number of rows by number of columns. Okay, this is what size does. And the answer, or what size is returning, if so, tell me please, what would be this one? What will be the result of this one? Without trying. But you can always try.
Only one.
One? No.
1, 2.
1 by 2. By 2.
1 by 2.
Yeah. Because size A is size of A, which is 3 by 2. Okay. And this one is size of A. This is 1 by 2. Okay. So for example, let's see. For example, you can write number of rows and number of columns equal to size A. Oops. Right. Okay. So now we have two variables. One is NR. We call that NR. You can call them whatever you want. I mean, the name is not important. So NR is the number of rows, and NC is the number of columns of matrix A. Okay. The other thing that you can do is to do it in this way. For example, NR is equal to size A and 1. Okay, so this tells you this is the dimension that you are interested. So when it's 1, means that rows, the number of rows. And if you try this one, it gives you the number of columns. When you put 2, you have a 2-dimensional matrix. 1 is the dimension of rows, and 2 is the dimension of the columns. Okay. Then we have also length. Let me print A again here. And we have length A. Okay. Length is actually max of the size of the A. Okay. Which is this length returns the size of the longest dimension. Clear? We have also null. So this is A and this is normal A. So what is normal A, guys? What do you think? It's simply the number of elements in an array. So we have 3 by 2 matrix. So number of elements is 6. Then what else? Okay, that's it. So an important point is, so we have A like that, okay? Indexing, when we want to refer to 1 or 2 or a set of the elements in a matrix or vector, how should we do that? For example, we write A 2 by 2 and 1. So it returns the element in the second row and first column, which is 3. Okay? Or we can write A 2 by 2. Second row and second column, it's 4. Or so this is A. Or we can also call A column, comma 1. It will refer to all the elements in the first column. Okay, column when it's allowed, it means that every element in that row or column. Okay, so A column 1 means that every element in the first column. Or for example, we can try a so it means that all the elements in the second row, which are 3 and 4. Okay, is that clear up to here?
Yes, yes.
So,
Yes.
yeah.
Clear,
We
clear.
can also use column to specify a range. For example, A 1 column 2 comma 1. So it means that from first row to second row and in column 1. From first row to second row and just in column 1. So it's 1 and 3. Okay, or you can type this one. I guess okay, so what is this one? It means from the first row to the second row, everything from the first row to the second row, and from first column to the third column, to the second column. So this is this part, right? Or you can also try with just 2 to 3. So what this one? What is this one, guys? Without trying. No idea?
It's the mud.
3, 5, 2, 4.
No, tell me that what this tells, not is the result. What does that mean? From okay.
From 2 to 3. From 2 to 3.
What is 2 and what is 3? From row. Yeah, from the second row to the third row. Okay, go ahead, Tariq.
And from the first column to the second column.
Okay, so it's this part, right?
Yeah. Yes.
So this is how we can, okay, so at some point, you don't need to, for example, you want this row and this row, or you want this element and this element. So you can, if you say that from first row to the third row, the second row also will be included, but you don't want it. How we can extract those elements? So you can write, for example, A1 and 3 and 1. Okay. This tells us, so this one is a vector, right? This is a vector. It's a vector of 1 and 3. Okay, it's a horizontal vector of 1 and 3. So it tells that, okay, I want the first and the third rows and only the first column of A, which are 1 and 5. Okay, or we can say that all the columns by putting column, I guess. Okay, so it tells that all the columns, but only the first and the second, the third rows. So this is another point, and okay, we can also assign to a specific. So at some point, just imagine that we need to change this row of A or this column of A or something like that. So this is A and
excuse me.
Yep.
How can you extract the elements on the diagonal?
Yeah, you can simply multiply it by identity matrix, I guess.
Okay.
For example, this is I and I mean A multiplied by I. But the point is that in this one, you need this to be a square. So let me do something. So we generate another matrix and we add so this is a square, and then okay, so you want A multiplied by I of size 3. Oops. Am I doing something wrong? Oh, yeah. Okay. Okay. Can you see that?
Yes.
So these are the things that we will see later on, but just okay. So where we are, okay, assignment. So this is A, and we want to change the first row with some other new values. Okay, we can write A. So to refer to the first row, you already know that it's like that, is equal to some new vectors like 100, 101, and 102. Okay, you see that the first row is now replaced by this vector, this new vector. And so I already did it, but I didn't explain that. So CLC, and so we have A like that, and we want to append a row to the bottom of this matrix. Okay, we write A. So when we want to go to the second column, we to the next column, we always use semicolon, as I already said, and we want to add, for example, some random numbers, 70 and 18 to the end of that. Okay, you see, A is already appended by this. So tell me, so what is the size? It's size A. It's 4 by 2. Okay. Tell me what would be the, let's see, A. If I write, for example, A is equal to 0.1 and 0.2. So what this one will? Oh. This is A.
It will replace the first row by 0.1 and 0.2.
No, it doesn't actually replace. It adds this to, yeah, exactly. Okay. So, oh, what did I do? Okay, this is the result. Can you see that, Tari?
Yeah.
Okay, so this is added to the beginning of the as a first row. So what else we can do then? This is A is sort of growing. Okay, how can I add a column to the left of this one?
Okay, I wanted to ask a question.
Okay, let me just explain this one and then we will. So just keep it in mind. So I want to add a column to the left of A. Okay, so what should be the size of the column? 1, 2, 3, 4, 5. Otherwise, you will get an error. Okay, so we need a column vector, a vertical vector of 5 numbers. Okay, 100, for example, 100, 1, 102, 103, and 104, for example, and okay, 105. Okay, so this is a column vector of 5, or oh, oops, it's 6, right?
It's 6.
Yeah, so this is 4. Okay, and what we want to add it to A, to the left of A. So this is the command. The other way is to simply we will add it again. So to simply store this in a vector, okay, and then A is equal to V, comma, A. It's added again, okay? If you want to add it to the right, then you have to do that. You see, the fifth column is added. So that's it. So this the last one. This is not necessarily a vector. It can also be. Let me clear everything and see. You can concatenate also two matrices. But the point is that their size should be somehow compatible to each other. For example, we have matrix A, and we want to horizontally concatenate that with another matrix B, which is 3 multiplied by 1. This is just to produce some distinguishable matrix 3 by 2. Oops. 3 by 2. Okay, so we'll see this is A and this is B. Okay, both of them are 3 by 2. And you can see, write C is equal to A, comma, B. So B is added to the left of that, to A. Or you can write, for example, B, A. So this is B, this is B, and this is A. Or you can write B, colon, semicolon A. So this is B, and this is A, or vice versa. Any questions up to here? Oh, I guess we reached to, wow. We were damn slow today. Okay, so we have about 5 minutes, right?
Yes, yes.
Okay, so we can do some operations like, so we have, these are matrix operations. We have A like that and B like that. So B is 2 by 4 and A is 3 by 2. So we can multiply them. This is matrix A, B, and the result should be 3 by 4, right? And you see that. Okay, was that clear? This is matrix multiplex. So we have 3 by 2 and you have 2 by 4. A 3 by 2 multiplied by 2 by 4 will be 3 by 4, which is C. Then, for example, we can produce a matrix of D with all with ones of 2 and 4. Okay, and this is C, and then you can and this is A and this is B. Okay, so size of B is 2 by 4 and size of D is also 2 by 4. Okay, and sometimes you need to just do element-wise operations. Okay, So this is B and this is D. They are the same. So I can change D. Okay. So you need to do the element-wise operation like that. So then you can multiply B, then dot multiplication D. So this is the element-wise. Each element in B is multiplied by the same element in D. You see? Or you can do the division, or yeah, you can simply add them. This is element-wise summation, or you can, for example, B with power of 2. Each element of B will reach to the power of 2 or 3. Okay, so when you add dots, it means that the operation will be element-wise. Or you can take log of D. So log is natural logarithm and it's element-wise. This is element-wise. And you can also try log 10 of D. This is common logarithm. This is with base 10, and you can also try X D. This is exponential. Then what else? You can also SQRT of D. This is this one. This is equal to D with power of 0.5. Okay. And yeah, that's it. So we will meet again, I guess, on Wednesday, right? Or Thursday?
Yes.
On Thursday.
Okay, on Thursday.
Thursday.
So yeah, I'll send you a text file with this commands that we tried today, and you just take a look at that, because yeah, you need to keep them in your mind and remember them, because later on we need to use them on the next lesson. Okay, so hope that it was useful for you, and if you don't have any questions, then goodbye and see you on Thursday.
Okay,
Goodbye.
bye.
Thank you very much.
Bye.
You're welcome.
Thank you.
Bye.
It's morning.
Hey, Yakubu.
Hey, good?
Yeah.
Yeah, Tarek, I just started reading the paper, what you sent me. So today I'm reading the papers and try to revise something in the evening. Then tomorrow, mine is in the morning.
Which paper are you reading?